So thank you everybody for joining us today. Before we get started, I have a small confession to make. Some years ago when I was a proposal engineer at ABB, I was working on a quote for a simulator opportunity and our customer was AES Alamitos. Then I switched job functions and became a simulation specialist. And sure enough, AES Alamitos simulator had been booked and was assigned to me as my first project. So I got to set it up, configure it, and commission it on site. So needless to say, I'm a bit biased when it comes to this project's success, as it had followed me throughout my different job functions. But luckily, Anshumann Bhalla from AES is here today with me to provide his own testimonial on their simulator success and in general on why simulators are considered the perfect training and testing tool for plant owners and operators. So my name is Sandy Bouissa. I'm ABB's regional digital lead and simulation consultant here in the US. And along with my discussion with Anshumann, I'll be offering you insights on how to pick the right simulator solution for your plant. So some webinar logistics before we get started. Everybody is on mute right now, all attendees are. If you want to submit your questions, please hover down until you see that bar down top where it says the chat. You just click on that and then you can submit your question and somebody will read it to us. You can submit it at any time throughout the presentation, so please do that. And like I said, you just have to hover over. And just to be aware, this event is being recorded and we have a small disclaimer on that. This is just a legal disclaimer for you to be aware of. The document is subject to change without notice. ABB is not to be held liable for any incident or damages arising from the software or hardware described in this document. All right, so for our safety moment, with working from home and kids back to school or being homeschooled, there's a lot of tips on trying to stay safe, right? So we have embracing the new homeschooling lifestyle. So if you are homeschooling, expect the unexpected, offer your attention and presence whenever you can, help children learn. If you're taking your kids back to school, obviously with traffic, be aware of that. With online schooling, cybersecurity is very, very important. Antivirus software is vital. Please invest in an effective software to make sure your devices are up to date with malware protection. I would also say be very, very skeptical about the latest and greatest offers or emails that are being sent with urgent instructions from your boss or your kid's school. Use strong passwords and last thing I would say, enable multi-factor authorization. And also back up everything, all your documents, because if your kids are touching your laptop, you want to make sure everything is backed up. All right, so for our tech talk today, I think I had already introduced myself, part of my small confession, but I am currently a digital lead, and this allows me to solve complex problems in the energy industry using ABB's latest digital solutions and technologies. My expertise and focus area involves simulation and digital twin, cybersecurity and optimization, and advanced control. As for my guest today, Anshumann Bhalla is the INC manager at AES Alamitos. He has extensive experience, about 21 years in the energy industry and control systems. He recently designed, constructed and commissioned a 640 megawatt combined cycle power plant. Plant controls included ABBS Plus, GE Mark VI, and Siemens T3000. Anshumann is also a domain expert in his field, where he designed and commissioned around 10 power plants globally. Among many things, Anshumann is a certified PE in California in control systems, a TUV certified functional safety expert for ESD, and a senior member with IEEE and a fellow with the Institution of Engineers in Australia. So I'm very excited for the knowledge that Anshumann is going to be sharing with us today. Alrighty. So for our agenda, and before we kick off the discussions with Anshumann, I'm going to be presenting some of the current energy industry market challenges, and then I'm going to share how ABB's tiered approach helps plants pick a starting point when it comes to simulator solutions. Alrighty, we can get going. So for the current market challenges, the top or the number one challenge that most plants are facing today is with the retiring workforce. The average turnover rate, and especially with the pandemic, in the US is about 44%, with 99% of companies being cited that finding new skilled hires was a challenge. So there's a lack of process knowledge capture. You're having all your seasoned operators walking out the door with 30 years of knowledge, and there's no real good way to capture them. So obviously that's a huge issue for the market, right? There's also the issue of the lack of process safety and risk avoidance, which results in delayed startups because of operator error and hesitation. 42% of unplanned shutdowns are caused by operator errors. And it's really not because the operator didn't know, it's because he hasn't been trained, in abnormal conditions. For plants that don't have simulator or a medium where operators can train on, they typically use the production unit. And when you're using the production unit, you're using it within the conditions that a unit is typically run in. You're not running scenarios where you're having trips or any conditions that are abnormal that you won't typically see. So the operators are not being trained on that, and there's really no risk avoidance. So how important is it to train operators to handle unexpected issues in a plant that is in continuous production, right? Another challenge would be for plants with high availability factors. They cannot afford downtime. They're already struggling to optimize production and reduce costs. So reliability for these plants is very important, and any downtime would result in a loss of revenue. Also, with new processes being introduced, shutdowns are required after logic modifications, which could result in commissioning delays and subsequently loss of revenue and income. So all these different market challenges, we can see how simulators evolved from being a luxurious add-on to a necessity or a necessary tool. So the question remains, though, how do we pick the right simulator solution? Okay, so here you see the plant on the left and the virtual simulator, which is a representation on the right. You have the plant's HMI here, and the virtual simulator would have the same thing. The control system is over here, and your soft controllers with the same logic is here. So what can we compromise on when we're trying to build a simulator? The top two things that, well, I should start with the things that we cannot compromise on. And the number one is your virtual controls. You want your simulator to have the same exact logic that is on the production unit. That is something that you definitely do not want to compromise on with having a simulator. This is the difference between an emulated system and a simulated system. With an emulator, its emulated logic is translated. It does not represent your exact control logic that is in your unit. So therefore, even if you have the highest of the high fidelity models, your model response is not going to be the same as it is on your plant. Another thing that we cannot compromise on is having the same HMI as the production system. So you want your simulator to have the same graphics, the same feel of your production unit. Another thing that we also want is good training scenarios, and this is with a good instructor station. You want to ensure repeatability of the training scenarios with predefined, with consistent interjection of malfunctions. You want to make it easy for instructors to measure and track performance. You want also to have the ability to expand the simulation solution over time. And by that, we mean if you were to add another unit, if you add another process, if you were to change something. So you want to have that capability to expand your simulator, not just have it, sitting on the shelf, not using it because you lost confidence that it does not match your production system. Now, things that we can compromise on include the model, the fidelity and the scope, whether or not you want to have function code models or high fidelity models, or maybe a mix in between. This is when we ask the question, where are the boundary conditions of your model? Do you want to have a plant response model that is very accurate, extremely accurate, or somewhat accurate? And all of that can be compromised on. And the reason being is it depends on the goals of your plant. If you want your plant to test logic, right? Obviously, you don't care if it has all the thermodynamics behind the models. If you want your simulator to be used for startup and shutdowns, obviously you don't want the high-end engineering grade simulator. You just care about those specific unit being modeled. But if you're doing designing and commissioning and you're doing you know, abnormal condition training, obviously you would want to go with a high fidelity. So these are all some things that we can compromise on. Scope of training scenarios is another. You know, this is where we go with the high with the fidelity. You want to add more malfunctions. You want to add more devices with level failures. And like I said, with the more scenario. And lastly, the simulation solution hardware. Do you want it to be an exact match of your control room, or maybe you can go by with a reduced set of machines? Some customers prefer to have the exact feel of their control room so that their operators, you know, think that they're actually in the control room, you know, and it helps them have that much faster of a response. So that's something that can be compromised on. Alrighty, so then moving on with the things that we can compromise on, how do we pick the model, right? Where do we start from? So we want to design a simulator to meet our plant budget, right? First and foremost, how much is it going to cost? And this is something that we have to look in more details, right? This is something where we have to look over your areas being simulated, again, discuss the goals that you're trying to achieve, because we want to design a simulator that can be accommodated for expansion over time. These are the things that cannot be compromised, right? So at the very base, you want to have the same controls that are on your production unit. For modeling scope, you can either have a function code model based simulator, or you can have a high fidelity model simulator. And you can see here, there's a lot of different tiers for the two different types. And again, it all depends on the plant goals, your budget, and how long or how much time you have before it can be delivered. So what's our ABB tiered simulator approach? At the very first tier, with the ABB control simulator, as we had discussed, you want to have the same virtual controls. So we have 800XA simulator and Symphony Plus simulator. With the 800XA, it supports AC800M and the high controllers. We have with the legacy control, it supports Advent Master, Melody, Harmony, and Freelance. For Symphony Plus, obviously we support Symphony Plus controllers, as well as any Harmony and Infinity controls. At tier 2, and this is where you start building on that simulator. So for tier 1, all we're doing really is, you know, testing logic. So if you're adding any IO cards, you're adding devices, and I just have a few points, a few devices that I'm testing, you can, you know, go by with just using your control logic and a virtual controller just to do some testing. Now, if we want to do more testing, and i.e. add a process model engine for 800XA simulator, this is possible with the ABB simulation models. We have a process model engine that includes IO and device feedback, loop feedback with simple models, and we can add a process power simulator, which includes the electrical models for your system. So this is all an added factor on top of your regular virtual controls. This would help you with virtual commissioning as well as operator familiarization. And similarly, for Symphony Plus, we can have ABB empirical modeling. So for our boiler turbine plants or combined cycle plants that have Symphony Plus controls, we don't have to go with the high fidelity, depending on the plant's budget, of course. We can do an empirical model, which correlates the data of the plant in order to give an output, a predicted output. So this is when our steady state conditions are realistic, our transient conditions are more representative, right? With the high fidelity, it's actually predictive. So this is the difference between the two. For the empirical modeling, you're using existing data. For the high fidelity, you're using equations to find out what that data is. And for the ABB empirical modeling, we can use it for virtual commissioning as well as the basic operator training. So last but not least, we have the engineering grade with the first principles models. And again, these are the highly tuned, high fidelity with a steady state condition that is near identical with less than 2% error deviation. The transient, like I said, is more predictive. Now, if we still want a high fidelity, but we're having issues with budget, we can lower it down a bit. We can have a highly predictive steady state and maybe a more realistic transient conditions. And all of this can be played with when it comes to modeling for areas. So say you have, I don't know, 10 areas in your project, right, or plant, but maybe you're good with just having the core areas being simulated with the rest being open loop. You just want a static quantity on there. You don't want it really to be simulated. That's possible. That would lower your budget down, but still give you that core areas that can be simulated. So this is what we mean when we say, you have a highly tuned, high fidelity or a high fidelity. And all of this can discuss based on plan. So when customers are trying to pick the right starting point, we start with the goals, and then we discuss, how can we fit a fidelity type based on those goals. All right, so our strategies to build a successful simulator include, what we do is we can help you prepare a business case. And this is when you schedule a one-on-one call with our experts to discuss your current challenges and how simulators can help. And secondly, we can strategize on a best solution. So we can schedule a plant virtual assessment. This is really digging deep into your project, into your 800XA engineering project or your Symphony Plus engineering project. We would dig deep to find all the areas, your controls, how many IO points, what areas would you like to be simulated, how many device malfunctions, process malfunctions, and whatnot. The cost benefit analysis would help with the fidelity questionnaire. So this is when a customer would fill out our simulation fidelity questionnaire, and we can discuss based on the answers which fidelity level would best fit their plant's budget and still not compromising on their goals or long-term performance improvement goals. Alrighty, and I think this is it for the presentation, and now I can turn it to Anshumann and our discussion. Let me stop sharing my screen. And I hope I didn't breeze through it. Alrighty. Hey, Anshumann.
Hello, everyone. Good morning to ladies and gentlemen on the west side of US, and good afternoon to people on the east side.
Anshumann, thank you very much for joining us today. I'm very excited personally. So before we start, though, I didn't ask you, are you affected by the fires at all in your area?
Yes, there is a heat wave right now in California, and our plant is under restrictive maintenance. So what it means is that, we have been told by the California government that we have to keep running. We have to keep running. We have to keep producing power. And we are not supposed to do any kind of, preventive maintenance right now, because there is always a scope of, production loss or something happening. So yeah, so right now it's a kind of a critical situation here in Southern California, and I'm a part of the ops team, operation team, and our job is just to keep the plant running.
Yikes! Yeah, I can only imagine. That's that high availability factor, I think, that we had mentioned before.
Yes.
More power to you, literally.
Right. We have to be like 100% reliable at this period.
Gotcha. So I guess, building more on that, can you share some of the major reasons that made your organization consider a simulator in Southern California or for your combined cycle plant?
Okay, so in 2017, we started designing and constructing these two power plants. One
Mm,
is the Long Beach, California, and the other one is at Huntington Beach, California. Both of them are combined cycle gas-fired 650 megawatt power plants. So in 2018, we wanted to build our O&M team, operation and maintenance team, and these were the repowering projects. So repowering project means at these sites, we already have got old plants, legacy plants, and we were having the operators and maintenance staff. We wanted to retain them. We wanted to hire them. That was, one of the decision taken by our ELT, executive leadership team. But the
mm-hmm,
challenge for us was that these operators were not having any experience on gas turbine and on the combined cycle power plant in general. So we came up, I was a part of the construction team, CMT, we used to call it, construction management team. And we decided to come up with a comprehensive LMS, a learning management program for our new operators and maintainers. And simulator was a very integral part of that training program, a high fidelity simulator.
mm-hmm,
And there was one more aspect to it. The way our EPC contract was written, after the substantial completion, the plant was supposed to be handed over to AES, and then the EPC contractor is gone, right? So there was no some kind of a transition like the operators from the EPC contractor is going to train the owners and operator. That kind of mechanism was not there. So it was very important for us to have some kind of a simulator during the construction and commissioning stage where we can train our operators, where we can give some kind of a confidence to them so that they can feel comfortable. And once the plant is handed over to us, we should be in a position to operate and maintain the plant.
gotcha. So I guess while going through that selection process for a simulator, I'm sure you had a bunch of criteria. Can you talk a little about what criterias you had for, I don't know, a quote or the proposal?
Yeah, so when we received this proposal, the main criteria for us was that whether it meets our requirement. And
Mm-hmm,
on the requirement side, we had a techno-commercial, requirement. So on the technical side, uh, we wanted our simulator to be as real as possible. So, that's why we decided that, okay, we will go towards a high fidelity model,
mm-hmm,
right? The other thing we wanted was, as a part of our requirement, integration between multiple control systems were very important to us because there was not one control system we are using in our combined cycle power plant. We have got a gas turbine. We are having Mark 60. We have a balance of plant. We are using ABB Symphony plus DCS. On the steam turbine, we are having T3000. And then we have got many skids. We are using Rockwell PLC control system for our aux boiler, for our fuel gas compressor, for our Demon water treatment plant. So multiple control system. And integration of those control system was very important for us in the simulator environment. Otherwise, the simulator solution itself would not have been feasible. So those were some of the major, technical criteria for us. And then on the commercial side, we always wanted to make sure that whatever budget which we have allocated for this simulation, the final proposal which we are getting, falls within the budget. One thing which I
mm-hmm,
haven't mentioned is, I'm talking about high fidelity simulator, and we wanted our simulator to be as real as possible.
mm-hmm,
So it was important for us to have virtual controls, in our simulator because emulation was not an option for us
mm-hmm.
because we wanted to train our operators, and there were so many other things we wanted to do on the simulator in terms of testing and commissioning and using the control system as a test bench. So it was imperative for us that we should use virtual controls in the simulator environment.
Gotcha. So did
Yeah.
you face any pushbacks with that?
Well, when we received proposals, one of the proposal was obviously from ABB and Western combined, and finally we opted for that proposal. We gave our, order to ABB Western solution. In terms of the pushback, I would say the major pushback was on the cost.
Okay.
So what happened was, in our case, uh, we had a capex budget for this power plant, for the two power plants.
Hmm.
Unfortunately, we haven't allocated uh, simulator budget as a part of our capex allocation. So simulator was just missed as a part of our EPC scope.
Hmm.
And then in 2017-18, when we started realizing that, oh, we need a simulator for so many reasons, then
Hmm.
what we decided that, okay, we'll use some of the contingency from our in our capex budget, and we
Gotcha.
allocated around $1 million for this high fidelity simulator. But the
Hmm.
proposal which we received, it was above our budget. So it
Hmm.
was important for us to work with vendors like ABB and Western to optimize the solution. And when I say
Hmm.
optimize, we started working on the scope, right? What we basically want in our simulator. So some of the things which we worked was, we decided what are the critical systems we need to have in our simulators, and what are the non-critical systems where we can compromise. So
Hmm.
one of the thing was like, we had a dim water treatment plant. So water treatment plant is an independent system in itself. And we decided, okay, since it's not a core part of the power plant production, we will exclude it from the simulator scope.
Hmm.
Similarly, the electrical system, we had a 230 kV switch yard, we had high voltage breaker switching, and we said it is good to have in the simulator, but it is not must to have in the simulation. So some of those things we excluded, and finally we got a scope which was like more realistic for us to have in our high fidelity simulator, and the
Hmm.
cost was also within our range. So those were the major pushbacks, but we were able to work against those pushbacks, and finally everything worked well for us.
Did it affect your goals from the simulator at all when you removed those few areas that you mentioned? Or
No,
were you
no,
still able to achieve the goals?
yes, I would say so. In terms of goals, what we wanted to achieve from this simulator, one was definitely the training of our operator,
Mm.
and we got this simulator in during the summer of 2019. At that time, the construction was happening, and we were just near to starting our commissioning. So we had a 6 months of comprehensive training program for our operators. uh, Operators were able to train on simulator, the various cycles, the startup cycle, the shutdown cycle. They were able to get an experience on a sequential startup, sequential shutdown, hot startup, sparging operation, blending operation, right? Bypass operation, which is so important for a combined cycle power plant.
Hmm.
And then we created various malfunction scenario in the simulator training environment. For example, we have got a redundant boiler feed pump, right? And if your plant is at a base load, at full load running, and one of the boiler feed pump trips, so you have a
Hmm.
disturbance in your system, right? And the other boiler feed pump is going to kick in, and then we told our operators how you are going to manage this scenario. Right. So those kind of malfunctions we created, and it was a very comprehensive training program for our operators, and they were comfortable after the training, and they were confident to manage the operation of the power plant once it is going to be handed over to AES after substantial completion. So that was one of the objective. The
Hmm.
other objective was, we wanted to use simulator for our virtual commissioning. And fortunately, what happened, we were able to get this simulator during the summer of 2019, before the start of the before the start of the commissioning itself. So, we tested all the sequences on gas turbine control, steam turbine control, balance of plant, and there were about 115
Wow.
disturbance, we call them DR, disturbance record. We found those were issues. We sent those issues to our OEMs. They were able to rectify those issues in the control system, in the mechanical system
Hmm.
before we started the commissioning. Just imagine if those kind of issues are happening in the real time during the commissioning, it could have easily delayed our commissioning by 1.5 to 2 months.
Hmm.
And during that period, we are having AES commissioning staff, ABB, our EPC contractor commissioning staff. It could have resulted in millions of dollars of
Well,
loss for us just because we are losing time during the commissioning. So I would say our simulator just paid for itself, because it contributed so heavily during
mhm.
the startup and commissioning itself. So these were our major goals, and we were able to achieve it, by having the high fidelity simulator on time at AES.
Mhm. Gotcha. So basically, essentially, I mean, simulators, as a number one goal would be to train operators more effectively, right? And then you mentioned commissioning, it would reduce commissioning, offset the delays. So for testing logic and graphics and whatnot. But did you see any additional benefits to having a simulator, across operations that are not necessarily those two things that we mentioned?
Right. So it's a very good question that, once your plant is commissioned, once you're in operation, how simulator can help you in the running environment.
Hmm.
In our case, my operating team, they are extensively using simulator even right now as we speak to create operating instructions or to update the operating instruction if they are already existing. So now we are at a stage at AES where we have got written operating procedure for everything, for hot startup, for cold startup, for bypass operation, for steam blending, for bottling up the system, for valve lineup, you name it. And my operating team has got standardized operating instruction. The way it helps us is that irrespective of whichever operator is now operating the plant, we have got written instruction which are standardized, which are optimized with the help of a simulator. So, so in a way, we are standardizing the entire operation of our power plant also, because all those scenarios, situations, we have got our operating instructions available. So that is one of the area, where we are able to use simulator in the production environment right now. The other thing is there are a lot of RCA analysis we are doing, the root cause analysis. It's a running plant. Sometimes we get strip, sometimes we get runbacks in the plant, right? Our gas turbine trips, steam turbine trips. We can have loss of production. We can have partial loss of production. So during those scenarios, we want to investigate. We want to troubleshoot what happened. What was the root cause of the issue, right? Who initiated the trip? And many a times we have to replicate that problem. So we are using simulator to replicate those kind of an issues to see what happened, whether we received the alarm or whether we were unable to receive the alarm, and whether it was an operator issue or whether it's an issue in the process control itself. Our logic is not correct, right? So those are the kind of things we are able to replicate. We are able to replicate the problems on simulator. We are able to test them, and it is helping us a lot on the RCA, which is like the root cause analysis.
Hmm. Gotcha. So I guess you mentioned the CapEx and OpEx improvement programs. Is that what you plan to use the simulator for? I guess above and beyond its current usage?
Yes, that's another thing. And so our plant is a new plant, right?
Hmm.
We just got our substantial completion in the month of February 2020, this year itself. So in the first few years, if you'll talk to any owners and operator, they will say it's a stabilization of the plant, right? The first few years is like stabilization period and optimization period. So there is a lot of process control optimization which we are doing in our plant. The plant is running, it is able to produce power, but we can't say it is optimized. So we are looking into areas like, can we improve on the efficiency of the gas turbine, steam turbine? Can we improve on the heat rate, right, by looking into the enthalpy and the entropy calculation? Can we reduce our gas consumption? Can we reduce our chemical consumption? We are burning a lot of ammonia, right? And then other chemicals. So these are optimization areas. And we are again using simulator because many a time we have to dig into the process control, right? And sometimes we have to we try to recommission a part of the system or the whole system in case if we find any issues. So simulator is helping us to even optimize our power plant and to standardize the process. Many a times I use the term process control optimization. So simulator is helping us in process control optimization of the power plant.
So you would run like what if scenarios using these optimization applications, and then you would implement them separately on your production unit?
Right. Like I'll give you a typical example. We had a sparging operation, and we realized that we are unable to bottle up our plant during the sparging operation. So in the sparging operation, what happens? It's a peaking plant. We have a peaking plant, so we are starting and stopping our plant almost every day. So when we shut down our plant is not running. We sparge the entire system with ox steam because we want to keep it warm. So the next time when we are starting up, we should be able to start it pretty fast. That is called sparging operation. So one thing we realized that we were unable to bottle up our complete system during the sparging operation, and we realized that we are having some isolation wall for our HP steam and the hot reheat steam. They were not getting closed during the sparging operation. So we decided, okay, we will just change this whole sparging cycle. So, so we worked on all the permissives and interlocks on the simulator system. We made those modifications, we tested them, right? So we had got this modified logic. We went back to our OEMs and we said that, okay, these are the recommendations from our side. We want to bottle up our system during the sparging. And they agreed, they accepted. And then we replicated all these change in the running environment. So now, now we have got a sparging system where we are able to bottle up our entire plant, and it is helping us to reduce our ox steam consumption, which is basically now we are burning less gas. So these are the kind of optimization we are doing, and we are using simulator to do those process control optimization.
Yeah, no, that's great. That's really the ultimate use that that would maximize your ROI on any simulator. I do have a question from one attendee. Does your simulator utilize emulated or virtual controls for the GE T3000 and Rockwell controls?
Okay, very good question. So on a GE, it's a virtual control. It is 100% replica of Mark 6C. So we are using the Mark 6C logic. We are using the Mark 6C controls, database, graphics. So it is virtual control. Now, as I said in the beginning, we wanted to rationalize and optimize the cost also, because simulator can become very costly, sometimes, if depending upon the level of the fidelity which you want and how real you want it to be, right? So on the PLC control, like the aux spoiler we have, and this the fuel gas compressor system we had, it is an emulation, but even in emulation we are able to use the actual graphics. So its logic is emulated, but the graphic are actual, so that's the kind of the modeling which ABB and Western is able to do it. So in terms of the graphic, HMI operator is getting a completely real feel, but for the Rockwell control logic system which we are having, the controls are emulated.
Now, does that affect the core the simulation areas from the Rockwell controls? I'm assuming those are FDIs.
No, I won't say, because look, if I talk about aux boiler, we just need aux boiler for sparging initially when when the plant is running, and then we use the Hershey steam basically for our gland steam and for all the other purposes. So aux boiler, yes, we need aux boiler. We can't start our plant without aux boiler, but it is still an auxiliary process, I would say, right? So, but yes, in terms of the graphic, we wanted to have the real feel, and that is that, so it is a kind of a decision making you have to do, right, at the time of business case. So that was not so aux boiler is not like, an integral part. It's not a core power plant process. We need aux steam, during the starting. So in our aux boiler, we have CCS, combustion control system, and then we had a BMS, burner management system. And burner management system is for safety, right? So burner management system is not used for control, it is just for safety. And we emulated it. So we are getting all the alarms, we have got the real graphics, but the logic is simulated. So it is a kind of a decision making, it depends upon the budget, how much we want to spend it. If it would have been a nuclear power plant, I would have, I would be more biased to go for all virtual controls. Just go for all virtual, because simulator is so critical for training, for testing, and for other reasons for a nuclear power plant. For us, it's a combined cycle power plant. We went ahead with the high fidelity simulator. Our gas turbine, balance of plant steam turbine is as real as possible, and on our auxiliary process, there is a level of emulation which we have done.
Gotcha. So essentially, there's a mix, I would say, but mostly core areas would have to be simulated. Maybe some FDIs, as you had mentioned, can be emulated because they don't affect as much the core processes. I do have one more question, and I think we still have some time to take it. How do you, or what do you think was the benefit from training existing operators? So your seasoned operators, were they able to get the same benefit as your new operators or the new hired employees?
It's a very good question. You see, trained operators, seasoned operators, how much experience you have, but when you are building a new plant, every new plant will have something new in it in terms of new processes, new system, new controls, or sometimes, the control system platform can be different, right? So yes, you can have an control operator who is working on a combined cycle power plant for last 25 to 30 years. So he knows the process, right? But but since in our case, in a new power plant, some of the processes can be new. Your bypass operation can be different. Your sparging can be different. The way you are doing blending can be different. The level of automation which you are doing in the plant can be different. Let's say if even right now in 2020, let's say if we are building 5 new power plants, those power plants can have a different level of automation. They can have a different control system platform, right? So simulator is even helpful, for seasoned operators, because they get a feel of, that new plant, how the new plant is behaving, what is the operation of that new plant, what kind of control system is there, what is the response time which they are going to get, in that new plant, and what processes are new. Sometimes in a combined cycle power plant, you use cooling towers. We are not using cooling towers, we are having air cooled condensers, right? So these are some of the differences. There is always going to be some small little differences. You will see, whether it's a coal fired power plant or a combined cycle power plant or a simple cycle, right? So simulator, I would say, is definitely helpful. And even in terms of alarms, permissives, right? Even a seasoned operator would like to understand what kind of alarm systems are existing. What are the priorities of those alarms, right? What is the response time available to him for those alarms, right? Because these are all the customization we do. So even for a trained operator, simulator will be helpful for that operator to get himself to customize, to understand the level of customization which is done in that power plant.
Mm-hmm. Gotcha. And I would assume, I mean, the same benefits would be propagated to the process industry plants, not only the energy industry plants, right? So like chemical plants, oil and gas plants, everybody could benefit from having, training their operators on ESD systems or any process safety, right?
Right. Yes. So my take is that wherever there is a process, wherever there is a process control, right? Simulator is one of the tool which can be pretty handy, whether it can be a petrochemical plant, oil and gas refinery, or an LNG plant, or an LNG terminal, or a crude oil refinery, or a naphtha cracker, right? Or some kind of a mining extraction plant like aluminum extraction or iron extraction plant. So all these have a level of process, right? Process control, process automation, and power plant definitely. Gas fired, coal fired, nuclear, hydro also to some extent. So all these are areas. All these are industries, utilities where a simulator can be very useful.
Mm-hmm. Gotcha. I think we're all right. I think we're having one more question. Let me see. Yeah. Um, Francis, is this a good time to wrap up? I wasn't sure if you wanted me to.
Hello, can you hear me?
Yes.
Okay, yeah. No, I think is excellent. I think you answer Anshumann answered the a couple questions we got from the audience. So fantastic session. Thank you very much, Anshumann. Very good. Thanks for your input.
Yes, thanks a lot, Anshumann, for joining me today and for doing this with us. I know you're probably so busy right now with everything that's happening in California, so please stay safe and keep the power running.
It's my pleasure.
Thank you, everyone. Have a wonderful day, everyone.
All right. Have a good day. Thank you.
Thanks, everybody.
Thanks.